we have one more thing to talk about with exponents, and I need to introduce you to fractional exponents. Fractional exponents are just another way of writing something you already know. They're just a little weird looking, okay? Notice I have a square root table here. These are the perfect squares and the square roots that you should pretty much have memorized. You should be able to handle at least through 144 without a calculator. We talked early in the year about square roots, okay? And this is how we talk the square root of a. That means what times itself equals a. So the square root of 64 is 8 because 8 times itself equals 64. Here's how you write that with an exponent. The square root of a is written as a to the 1/2, okay? So a fractional exponent means a root. We know it's the square root. I think we talked about this way early. I'm talking first couple of weeks of school. There's a 2 there, the index, that we don't write when we're talking about square roots. So the square root, whatever the root is, that becomes the denominator of the root, okay? Here's how we do these. 49 to the 1/2 power, that means, since it's 1/2 power, that means the square root of 49. 49 to the 1/2 means the square root of 49. Square root of 49 is 7. 36 to the negative 1/2 power. Well, that's a negative exponent. That means we've got to fix that. How do we fix a negative exponent? Well, we say 1 over 36 to the positive 1/2. We take the reciprocal, just like we've been doing. Well, now we have 1 over the square root of 36. And the square root of 36 is 6. So my final answer is 1/6. Okay? Now, here's where it gets even weirder. What if we have this improper fraction looking thing? What if we have 25 to the 3/2? Well, we're going to use some of our exponent rules and we're going to rearrange this. We could say, let's use our power to a power rule. We could say this is 25 to the 1/2 raised to the 3rd power, right? 25 to the 1/2 raised to the 3rd power, because if we multiply 1/2 times 3, we get 3/2. Now, let's use what we know about the half power. The half power, or 25 to the half power, means the square root of 25 to the 3rd power. That's going to be 5 to the 3rd power, and we get 125. So the top number, you raise it to that many times, or you raise it to that power. The bottom number, you take that root. So this is the square root of 25 raised to the 3rd power. Let's look at one similar to that. 4 to the negative 7/2. Well, this is a negative, so I need to fix it first, right? 4 to the negative 7/2, using my negative exponent rule, my reciprocal, I'm going to say 1 over 4 to the positive 7/2. Right? Now, this is the square root of 4 raised to the 7th power. So let's write it that way. This is 1 over, that denominator of a 2 means the square root of 4 raised to the 7th power. This is the root. That means take the square root. The top number means raise it to that power. So the square root of 4 is 2. We're going to raise that to the 7th power. I'm going to use my calculator, my power button, and I get 1 over 128. Look at those examples carefully. Make sure you understand where all the steps come from. Now, cube roots. I don't remember if we talked a whole lot about cube roots, but a cube root is what times itself 3 times equals a number, okay? So, for example, the cube root of 343 is 7, because 7 times 7 times 7 equals 343. Now, I've given you a table up to the cube root of 1,000. You can use your calculator, but we're not going to look at real huge perfect cubes because they get big pretty quick. Now, based on what we just talked about, if I had the cube root of a, how could I write that using a fractional exponent? Well, my index, the number out here by the radical, is a 3. So the cube root of a would be a to the 1/3. That denominator equals your root. So that since this is the cube root of a, we put a 3 in the denominator. So very similar. Let's look at a couple of these. We have 216 to the 1/3. That means the cube root of 216. You're going to look in your chart over there. The cube root of 16 is 6 because 6 times 6 times 6 is 216. 64 to the negative 1/3. Fix that negative exponent. Take the reciprocal. So that's going to be 1 over the cube root of 64. The cube root of 64 is 4, so that becomes 1/4. Now, same thing here that we saw before. We've got 27 to the 2/3. That means the cube root of 27, since my denominator's 3, I'm going to take the cube root of 27, and then I look at my numerator, 2, and I'm going to raise it to the second power. The cube root of 27, I look at my chart, is 3, because 3 times 3 times 3 is 27, and then 3 squared is 9. Why don't you try D? Pause the video, try it on your own, see how you do. So I had 8 to the negative 5/3. I took the reciprocal and got 1 over 8 to the positive 5/3. My denominator is 3, so that means I'm taking the cube root of 8. My numerator is 5, so I'm raising it to the 5th power. The cube root of 8 is 2. 2 to the 5th power is 32, so my final answer is 1 over 32. Here's what we're going to spend a little bit of time on tomorrow. We're going to use our exponent rules and simplify expressions that have fractional exponents. Same rules apply, it's just now we're dealing with some fraction rules, okay? So here I am multiplying with the same base, right? Multiplying with the same base. What do I do to the exponents? I add. So this is 8 to the 1/2 plus a negative 5/2. Okay, we're adding those. You don't always show that step, but that's what we're doing. So I have 8, 1/2 plus a negative 5/2. Different sign, subtract. I get negative 4/2. I can simplify that. If you can simplify a fractional exponent, do it. That's 8 to the negative 2. All of a sudden it's looking kind of normal. That's 1 over 8 squared, which is 1 over 64. Okay? Look at the next one. 3 to the 5/3 times 3 to the 0 over 3 to the 2/3. Well, the first thing I notice is I've got this 3 to the 0 power, right? What's anything to the 0 power? That's 1. So I really just have 3 to the 5/3 times 1, which is 3 to the 5/3, over 3 to the 2/3. Now, I'm dividing with the same base. What do I do to the exponents? I subtract. So 3 to the 5/3 minus 2/3. That is 3 to the, if I knew how to subtract, 3 to the 3/3. Can I simplify that? I can. That's 3 to the 1st power, which is 3. Okay? Now, look at this next one. I see 6 to the 4/3 times 6 over 6 to the 1/3. I've got this little 6. I know it has a 1 right here. I don't want to do all that ugly fraction work. But I noticed this looks like it might turn out kind of nice. Okay, so I'm going to do my fraction rule there. I'm dividing with the same base, so I'm going to subtract the exponent. So I get 6 to the 4/3 minus 1/3, and I've still got this other 6 out here, right? So 6 to the 4/3 minus 1/3 is 6 to the 3/3 times that 6. That's this 6 right here. It's just sort of tagging along right now. Look at this. This simplifies. That's 6 to the 1st power, and 6 times 6 is 6 squared. That's the sort of thing we're going to practice with. Watch it all again if you need to. Write any questions you have, and I'll see you in class.